Alrighty, guys. As you know by now, hopefully, we do have an assessment coming up on Wednesday or Thursday, depending on what class you're in. So I just want to kind of go over the review here for you, so that way you have it. So Monday and Tuesday, what you can do is just watch this review video. I posted a blank copy of the review, so if you'd like to work alongside of it or try it on your own, you have that opportunity. Okay, so first things first here, you see all these 3-star questions, they will not be on the actual assessment, okay? However, it would be good for you to have these. I know we wrote them down on the last parallel review, so check those out. From there, I'm going to go ahead and skip ahead just so that way we can make sure we have enough time to get through all of this stuff. Okay, so your first part here is going to be a, these are all multiple choice right now. So your first part here is it's just simply, okay, reduce your radicals, okay? So in this case, remember what we're doing is we're looking at, okay, is it a square root, is it a cube root, and then we follow our rules from there. In this case, for number 6, it is a square root. Okay, so what I'm going to look at is, can I take the square root of 36? The answer is yes. The square root of 36 is 6. All right, and then when I do the variable, what I do is I look at the exponent and I divide by the index. Okay, so on a square root, the index is 2. So if I look at that exponent's 36, I have to divide 36 by 2. Okay, which I should get 18. All right, and that would actually be my answer. Okay, so nice and easy. We start off pretty simple. Everything is working out perfectly. Okay, if I go to number 7, I notice I have a cubed root this time. Okay, with the cube root, again, same process though. Instead of taking square roots, I'm now taking cube roots. All right, so I look at this, and first question I look at is, can I take the cube root of 64? Of course you can. The answer is 4. Okay, then instead of dividing my exponents by 2, I now divide by the index of 3. Okay, so the index of 3 here, we've got 27 divided by 3, which is nice and even. Okay, so that is 9. All right. When I look at 64, unfortunately, 64 cannot be divided by 3, but you can get pretty close. The closest thing to 64 that is divisible by 3 is 63. Okay, and 3 goes into that exactly 21 times. Okay, so 21 times 3 here, you get 63. So realistically, what I'm looking at is, well, what is 64 minus 63? Well, that's 1. So that tells me that's my remainder, which means I will have a little root here with the remainder of a b in there, just one b, or b to the first power. However you want to write it is up to you, but both answers are acceptable. Okay, going over here to number 8. All right, obviously this would be number 3 on your actual assessment. Okay, you've got numbers on the outside of your roots, okay, and numbers on the inside of your roots. So your first thing you want to do is multiply everything together. Since these are all square roots, you can do this. Okay, outside goes with the outside, inside goes with the inside. Okay, so 7 times 3 is 21. All right, inside I have 8 times 6. Okay, which 8 times 6 is, why can't I think right now? 48. Okay, and then finally you've got x cubed times x. Okay, so when you multiply variables, remember you just add the exponents. So this would be x to the 4th. All right, now I gotta look, can I reduce this in any way, shape, or form? The answer is yes. Okay, so what we gotta do is we gotta figure out what perfect square goes into 48. Okay, and then when we get that answer, what we're gonna do is we're going to go ahead and multiply it by what's on the outside. Okay, so in this case we have 21 on the outside. So what we're going to do is when we get our answer, we're going to go ahead and multiply by 21. So what I have here, 48 can be broken down into the square root of 16 and the square root of 3. Okay, square root of 16 is 4. Square root of 3 I can't do anything with. Okay, and then I notice now I have 4 on the outside, so 4 times 21. Okay, so this takes up a little extra space here, so I'm going to scroll over a little bit. So 4 times 21 here, I'm going to get 84. All right, so got 84 now on the outside. Okay, I still will have to add this root 3 in, but first I'm going to take care of the exponent. And again, remember square roots tell us to divide by the index is 2, so 4 divided by 2 is 2, so I have x squared. Okay, and then finally that root 3 comes along. Okay, so this one's a little bit more challenging. Requires you to do a little bit more work than the others. Okay, finally this last one. Okay, you have some division going on here. All right, so again, it's all under a square root, so you can go ahead and actually do this. So I believe what we get here is the square root. So I'm going to divide first. Okay, so 108 divided by 3 is 36. Okay, then when you are doing variables, what you do is actually subtract the exponents. So 12 minus 8 is 4. Okay, and then 5 minus 1 is also 4. Okay, so that's what that big thing is reduced. Okay, now I just go ahead and follow my rules that I've been following. Can I take the square root of 36? Yes, I can. That is 6. Okay, and then remember my index is 2, so divide all your exponents by 2. So that would be your answer there. Okay, so pretty straightforward. Remember, this is open notes, so you guys should be able to, what I would do is I would take down some notes from this and use it to help you out. Okay, so this next section, we'll just do this. To simplify the following radical expressions, assume all variables are positive. Okay, so that means if you get anything that's negative variables, you want to get rid of those. Okay, in this case, it doesn't look like there are any variables in here, so we don't have to really worry too much about that. Okay, so to begin, in order to add or subtract square roots, they all have to be the same kind of root. Okay, right now I'm looking at this and I don't see any roots that are the same. Okay, so I have to make that happen. All right, so first thing I'm going to do here is I'm going to figure out how to break down 75. Well, 75 breaks into 25 and 3. Okay, so the square root of 25 is 5, and the square root of 3 I don't know, so I leave it alone. Okay, so now what I'm going to do is I'm going to use that root 3 as a base for myself, so that way I understand that maybe I can divide all of those by 3 and get something down to it. So what I have here is I know this is going to have a root 3, and I know that 27 is going to have a root 3. Well, I can say this is 9 times root 3, and I believe that this is 16. Okay, so I'm going to just put my signs here. All right. Okay, now they are all root 3s, nice and simple. Just go ahead, add the numbers on the outside or subtract depending on what you see. So 5 plus 4 is 9, minus 3 is 6, and of course they all have that root 3. So you go ahead and you leave that there. So there's that. All right, number 11. Okay, this is a FOIL situation. Okay, so remember FOIL is first times first, so root 5 times root 5. Okay, remember if you're doing a root times a root, if you want to, it's really just what's underneath, but you can remember this trick. If it's the same root, what happens is just the number that's underneath comes out. If you don't remember that, what you would have gotten would have been the square root of 25, which is indeed 5. Okay, so you can go about that either way. Okay, the outside numbers times each other, so root 5 times negative 4, which is negative 4 root 5. Okay, the insides times each other, so negative 3 root 5. And finally, your last numbers times each other, which would be a positive 12. Okay, now what I'm going to do is I'm going to go ahead and I'm going to look at, do I have like terms in here? Yes, I do. These two are like terms as well as these two. Okay, so I'm going to go ahead and make these different symbols here. Okay, so the 2 on the outside, 5 plus 12 is 17. Okay, and then on the middle I have negative 7 root 5. Remember, if they have the same root, you can go ahead and add them. From there, I'm stuck. I can't do anything, right? This has a root 5. The 17 does not. So, therefore, you cannot combine any more like terms, and that actually is your final answer. All right, number 12. Got to zoom way out for this one. Okay, so we see the Cree Park District is designing a hexagonal flower garden where each pair of opposite sides are equivalent. Okay, what is the entire perimeter? So remember, perimeter means to add everything on the outside. Equivalent means equal, right? So it says the opposite sides are equivalent. So if I'm looking at this, okay, I have 2 root 2 is the opposite of that side. 4 root 3, okay, come on, why is this not working? 4 root 3, okay, and then finally 5 root 2 is over here. Okay, so all you're doing is adding your like terms. Okay, so in this case I have 2 root 2, 5 root 2, 2 root 2, 5 root 2. I cannot add the 4 root 3's to it physically because they have root 3's and I'm looking at root 2. So we start with that. So 5 plus 2 plus 5 plus 2 is 14. Okay, now with the root 3's though, they are like terms to each other, so I can go ahead and add those together. Come on. Okay, so that would actually be your answer there. 14 root 2 plus 8 root 3. I apologize for the bad handwriting there. The pen was not working very well. So we'll just kind of move on then. The volume of a cube is given by the formula volume equals the sides cubed. Okay, so where S is the length of a side, if a cube has a volume of 125, find the length of each side. So basically what it's doing is it's saying, hey, you have the volume of a cube is the sides cubed, okay? So we have to figure out how do we get rid of a cube. Well, how you get rid of a cube is you cube root, okay? So really, realistically, all I have to do is take the cube root of 125, okay? Which is, if I'm doing this correctly, is 5. So it's actually a pretty simple problem. It's a lot of words for not a lot of work, okay? And that's it on that one. All right, which expression does not equal 13? Oh boy. Okay, so what you're doing here is we are foiling every single one of these, and if it doesn't equal 13, that's your answer. Okay, so really quickly here, I'm going to foil this quickly because I'm running out of time. 4 times 4 is 16. Okay, I have 4 and negative root 3, 4 and positive root 3. Those will cancel out. And then finally, these two together, which would be minus 3. So this is 13. Okay, so that's not my answer. Whoop. Okay, going in here, 5 times 5 is 25. Okay, again, I have exact opposites, so my middle term is going to cancel out. All right, and then finally, I'm going to have minus 12 here. Okay, 2 times 2 is 4. Root 3 times root 3 is root 9. You take the square root, it's 3. So 4 times 3 is 12. And of course, this gives me 13. So that's not my answer either. I don't know why the first part of the 3 disappeared there. Okay, going to this next one. 6 times 6 is 36. Okay, go ahead and, you notice again, we have perfect opposites. Okay, so basically it's going to come down to this, all right, which is also 13. Now at this point, I know D has to be my answer. Has to. Okay, just based on the fact that the first 3 were 13, there's no way D is going to be 13. Okay, so there's part 1 to this video. All right, part 2 will be done shortly. But yeah, that's part 1 of your review.